Hi everyone, last item for this part of the data science tutorial is NumPy. We're going to use NumPy a little bit later on, but pandas are really our biggest one. NumPy is very similar to MATLAB. It's a very fast mathematical library. It's a third party or open source. Most of it's written in C or C++. NumPy is automatically part of Google Colab. If you're going to use this at home and like Visual Studio Code, you'll need to install NumPy. So this gives us the NumPy version in Google Colab 2.0.2. In NumPy, computations are done directly over arrays. That makes it way faster because it does everything all at once, just like MATLAB does. So here is our account transaction. Instead of going 100 plus 200 plus 300, the whole thing is added up all at once. So NumPy is very fast with, you guessed it, numbers. You can also add things directly to an array. So here we have an array, a NumPy array, with the syntax 1, 2, 3. This will add 1 to each element of the array A and create an array C. This will multiply times 2, and it doesn't do it one at a time. It does it all at once, which makes it very fast. Well, you can't see that it's very fast. When you're doing it here. You can also add arrays together. So it goes 5, 7, 9, and it does it all at once. It's very quick. Here's a little tutorial. We're going to use some real data for 5 popular video games. I've never heard of these, but we'll see. We're going to analyze video game sales using NumPy. Here's just a little data set that I found. I can't remember where. This is 1.5 million, 0.8 million. So that's lots of money. It's also distributed amongst parts of the world. North America, Europe, Japan, and others. Well, we're going to calculate statistics for the data set. So you get used to working with this. You'll want to type in that code. So I've got it right here. So I'm going to copy and paste it in, then we can see what it looks like. There we go. So total sales for each game, 3 million, 4 million, 6 million, 1.8, 8.3 for each of the games. And then with this, we're going to do the average sales. There we go. And there's the average sales for each game. We can also do lots of other things with NumPy. We can create an array, manual entries. We can access a single. Does this look familiar? Does this kind of look like Python lists? Oh yeah, it is just like Python lists. Does this look like a Python two-dimensional list? Oh yes, it looks just like it. It's created a little bit differently, but it works very much the same. You would access a two-dimensional array by row and column. So row 1, column 2 would give us 6. Oh, just a second here. I better run that. Oh, I didn't create my array yet. Okay, so there's my array. We scroll down a little bit. Create a two-dimensional array. All right, so I got the wrong array created. There we go. So now it should work. There we go. We can access them individually. We can, yeah, well, that's not going to work because I'm not printing it, am I? That's why I'm not seeing it. Just a second. print. And all right, let's print that. There we go. So that would be 1, 2, 3. That'd be 0, 1, 2. So that's the second. And it's the first row, 0, 1, second column. 0, 1, 2. So we come up with 6. We can access them individually. We can create a zero array, which is handy sometimes. We can create a range of values. Can specify a starting point. Linspace allows us to put things, create, very much like MATLAB. It allows us to create equally distributed numbers with certain steps. They support slicing. Okay, well that's just some of the basic stuff. Now there is, oh, look at that. We have all kinds of NumPy. Ooh, look at all that stuff. NumPy stuff here, NumPy stuff there. It all does all sorts of statistics. However, there's one that's missing, which is mode. So from SciPy, I imported stats. Who knows why? Anyway, we have all kinds of statistics. Uh-oh. That one I didn't like. Didn't really need that line, so I took it out. So we're importing NumPy. We're initializing a random number generator. Now this randomly generates random real numbers. That means decimal numbers. We're making an array with 20 of them. We're going to calculate the average, the mean, the median, on down the line, except we don't have mode in NumPy, so I had to bring that in from SciPy, and there's all of our statistics. Whoa, baby, look at all that stuff. Couple of things you want you to do. Create a 2D NumPy array containing 4 values. Create a 1Py array of 10 integers. Compute the mean, median, average. The further you can experiment with this stuff, look up stuff on the internet, try different programs, the faster you will learn it. Talk to you later.